Good morning, everybody. So here we are starting the second half of this chapter, and it is about law of sines and law of cosines, and we're also going to find the area of a triangle. So very quickly, to solve a triangle means to find all three angle measurements and all three side measurements. Now, up to this point, a lot of your math problems dealing with triangles have been with right triangles, and right triangles are amazingly helpful. We love right triangles because we can do SOHCAHTOA, which means we could find all the angles, and we have Pythagorean theorem, which means we could find all the sides if we just have a little bit of information. So right triangles are great. What if you don't have a right triangle? Well, you could construct a right triangle and then go back to SOHCAHTOA land, but there's a way to that has been done, and the results are basically these two things: law of sines and law of cosines. So the law of sines and law of cosines will help us solve acute or obtuse triangles without referring to SOHCAHTOA and Pythagorean theorem. So here, you remember from geometry, these are all the possible relationships you can know about a triangle. You can know all three angles, one angle and two sides, one angle and two sides, but the two sides are adjacent to the angle, etc. So angle, angle, angle is one of those situations that just cannot be solved. You cannot determine all three sides if the only thing you know are all three angles. Side angle, we can use the law of sines, but side angle side, we need the law of cosines. Angle side angle, we can use law of sines. And I want you to kind of be thinking, well, what is it that goes into the law of sines category versus the law of cosines category? And side is used by the law of cosines uses that. So what do these triangles have in common that is missing from these two triangles? And if you're a very keen observer, you will notice that in all three of these, you have an opposing relationship. You have an angle and the opposing side. So for here, you have this angle and you have the opposing side, 5. Here, you have these two angles, which means you could just subtract from 180 and find this angle, and then you know its opposing side. And here you have this angle and this opposing side. Actually, these two things are pretty much the same. With the law of cosines, you don't have that. You have this angle, you don't have this side, nor can you find it by Pythagorean theorem because this is not a right triangle. And here you don't know any angles. So you have no chance of an opposing relationship. So when you have an angle and its opposite side, we could do law of cosines. Law of sines. So what is law of sines? Law of sines is this proportion. These ratios, the sine of an angle over its opposite side, is equal to the sine of any of these two angles over their opposite side. And ratios can be reciprocated like this. So this thing in the yellow box is true, which means that this is also is true. They're both the same thing. Let's put this into practice. So here I want to solve this triangle. I know one angle A, and you know side A. So that tells you you're doing law of sines. You've got the opposite relationship going on. You've got an angle A and its opposite leg. And you also happen to know one other leg. Of course, it's worth mentioning this is not a right triangle. If it were, it's much easier to do SOHCAHTOA and Pythagorean theorem, but this is not a right triangle, so we're stuck. So how do I set this up into law of cosines? The sine of 136 divided by its opposite side is equal to the sine of C. I can pick any two ratios to set equal to each other. I chose C because I know leg C. And now I just had to do some algebra. I'll divide this out and then multiply by 15, and I get that. But now what? Now what do I do? The sine of angle C is equal to this, which means on the unit circle, the y value is 0.3. So that's like that. And there are two angles, it looks like it could be, whatever angle that is, but also this bigger angle. Now, we're about to use sine inverse. And we studied recently that sine inverse has to be a function, so sine inverse is only going to give us one angle, and your calculator will always follow that rule, so never fear. This is definitely a calculator portion of the chapter. So when you use sine inverse in your calculator, it's going to give you this angle, whatever angle that is. But we have to remember the context of our problem. We're talking about a triangle, and a triangle has 180 degrees. So this angle, this bigger angle, we might have to think about as well. So let me go to my calculator. And I just Googled calculator. Here's INV for inverse. It is defaulted to radians, so you have to make sure you're in degrees. And sine inverse of 0.37213 is 21.847 degrees. So angle C is 21.848 degrees. That's this little angle. If you subtract from 180, this bigger angle is 158 degrees. 158 degrees also has a sine of 0.3, but of course it's too big because I know one angle in here is already 136, so there's no way it could be, you could have a second angle of 158. So now I know angle C. I know two angles in my triangle, so I could subtract from 180 and get the third angle. And now how do I find this third side? Forget Pythagorean theorem, it's not a right triangle. You just have to do law of sines again. So I would do the sine of this angle over B, my unknown, which is this ratio, over any two relationships. So the sine of 136 over 28 is what I chose. And then you solve for B, and you discover that B is 15.199. Let's do another one super fast. So here I have these three, which I've labeled right here. Remember, to solve the triangles, to find all three angles, all three sides. And I need to set up a relationship. I have an opposite, an opposing relationship. I have an angle B and its opposing side, side B. So that is part of my ratio, the sine of 47 over 21. And I set it equal to the sine of A over 8. I multiply both sides by 8, divide this out, and I discover that the sine of A is 0.27. And I again go to my calculator and do sine inverse of 0.27861. And my calculator tells me the degrees is 16.177. But also remember, it could be 16.7 degrees. That has a sine value. That has a sine value of 0.27, but also 16 degrees up this way. So this bigger angle is 163. So you just take 180 minus 16.177, and you get 163. Well, which angle is it? And 163 is again too big, because if you have a triangle where one angle is 163 degrees and another angle is 47 degrees, you're already at 210 degrees. And a triangle only has 180 degrees. So that's an extraneous solution. We reject that. And then now that you know angle A, you subtract from 180 to find angle C, which is 116. And then you set up your proportion one last time to find side C.